the module. Similarly, we are going to import numpy, and now numpy as np means np is nothing but here a nickname kind of a thing that we have given, right? So pseudonym we have given for our particular use, right? Or else you can even write numpy as numpy when we are using, right? So first we'll understand why we are going to use numpy. Okay, now here we are going to create one particular function, right? So the function here is, let's say, let's come from the beginning, becomes easier for understanding. So now we're learning by exercise. Here this is the header in function. Okay, so the name of the function is list version, and size of array is the parameter that we are passing, right? So for example, whenever we do a function call, for example, if the size, we can pass 1000 also, so it is going to take 1000 and pass it within the function, right? So for here, what we are going to do is, first I'll explain the function. Here we are running a creating variable which is a, and we are going to generate a list using the range function, right? So it is start from 0 till, for example, if you are passing 1000, a will have the list of elements from 0 to 1000, right? If you are going to pass 5000, a will have list of 0 to 5000. Now b is also a range of same number, right? Now c we have created is 0, right? So basically we have created another initialize another variable, and we have given is the initial value 0. Now we have run a for loop for I in range length of a. What this does is, for example, length of the list a, if it is 10, it will run from 0 to 10. Like when we pass 20, that is how it ran, right? So it is run from 0 till 10, or whatever the length is there. For example, if we are going to pass 1000, it is going to take from 0 to 1000. Now whenever it is 1000, what we are doing, we are making the list C and adding. So we are, by giving square brackets, we are telling that this is also going to be a list, and here we are going to add the first index in A and then B, right? If it is 1 and 1 in that particular list, so going to C is going to be 1 plus 1, and we are doing it for I in the same range, right? So in the range that we have given, right? Then what we are going to do, we are going to return something called the time it took for running that particular statement. Okay, so we created a variable called time, and we have imported the module time so that we can know what is the current time. Like for example, when before running the program, we are saving the value of current time in t, right? So let me first run this and show t is equal to time. Now this will give something called an epoch value in time. You don't have to remember this. This is just helpful. Time value. Okay, this will not be like our current time, right? So I'm going to print t. Okay, so if I'm going to run this, so this is the time. Okay, so now for example, after some time, now the program ran. So now it was like 537. If you're going to run it again, it will be 548. Okay, so now it increased, right? So whenever you keep running, the time gets updated. So we are running the time before, we are saving the time of before the program ran, and after the program has ran, what we are doing, the time that it took at that, whatever the time is there, that particular time minus the initial time. For example, we started running the program at 10, and at 11, after 1 minute or 1 second, what we have done, we have removed the current time minus the time it was there in the beginning, right? So 11 minus t. Okay, so because it was 10 back before we ran, right? So it will give us 11 minus 10, because now it is 11, then we'll give 1, right? So that is where we'll know how much time this particular program ran. Okay, so how many of you are clear with what we have done, what we're trying to do here? We are trying to make a function. In that function, we are going to initialize a variable called time, and we are towards the end, we are going to see how much time it took for us to run that particular function, right? So if you understood this, type U in the chat box. Thanks, Vijay. Okay. Thanks, Sham. So if you have not understood, type N in the chat box so we can explain that. Okay, so everybody understood, right? So similarly, we are now creating a Numpy version. So how we are going to do it? So we are going to say, we are taking the time before running the program. Then we are creating two variables like how we have created here, and we are using a function called arrange, right? So what arrange does in Numpy is something similar to a range only, but it will start from 0 till whatever the size we are giving, right? So this will also be in the same fashion, right? So here we are using for loop in the first list version, because in list you have to add first element with first element. But in Numpy, you can directly say a plus b, and it is going to add the first element with the first element of b, right? So now again, we are going to return the time it took to run that particular version. Okay, so now if you see here a little simplification has happened by using Numpy. You do not have to use for loop, right? Because when you say c equal to a plus b, it's going to add item to item. Okay, so here what we have done is, as we have initialized here Numpy as np, here we are going to run np.arrange the functions in that particular module, right? Here you can even write Numpy, but to make it easier, we're going to run it as np, because we have initialized it as np. Okay, so now I'm going to run this also. Now I'm going to run the list version also, right? So now the program knows there are two functions. One is the list version, and then the other one is the Numpy version, right? So now we have created we are saying the size of the array is 1000, and we are going to run the time taken using this particular list, right? And using the Numpy. And what we are going to do, we are going to call that particular function by passing the size of the array. Okay, so I'm going to run this. You can see the same thing that even Professor Rajiv has done. He's also done this in his exercise. You can even go through Rajiv's exercise also, right? So the size of the array is 1000, and when the list version took 1000, it came here and it printed 0 to 1000 and b0 to 1000, started adding 0 with 0, 1 to 1, and everything got added like that. To run that, it took 0.27 seconds. But by the same thing we have done with Numpy, and it almost just took 0.00. And if you look at even the next numbers, then it took 0.0005. Right? It is in that degree efficient than a list version. So that is where we use Numpy. So now this explains us like how Numpy is saving our computational power, right? So instead of using just lists, we use Numpy, right? So like for example, we are going to pass, let's just say 10,000 in the size of the array. First, the list version will take 10,000 and keep adding element to element, and the Numpy version also will take 10,000 and it'll add element to element. Then this particular statements will give how much time the list version took and how much time the Numpy version took, right? So it's going to take a little time because we've given more numbers right now, so it's adding each of the numbers. So now you can see that the time taken using list, which is the maximum amount of time, it took 29 seconds, but the Numpy statement ran in almost 0.01 seconds, right? So you can see that how efficient Numpy is. It's not even 1 second, it is 0.001 second. So how many of you understood that we use Numpy because it is computationally lighter and efficient, right? If you understood why we use Numpy, type U in the chat box. Thank you, Rajvi. Thank you, Sojanya. Okay, so if you understood this, the people who are watching on YouTube, you can type in the chat box U. Great. So that is why we use Numpy over lists, because it is times efficient than list. Okay, so similarly, like how we have seen in lists, whenever we use a range of 10 and 10, the lists are appended. Like for example, X is a list from 0 to 10, Y is a list from 0 to 10. These both are getting added. So 0 to 9 and 0 to 9 get added. But in Numpy, it is 0 for 0, 1 for, like, every element gets added with the other element, right? So that is the difference between the range with lists and a range in Numpy, right? So now if you look at understanding arrays also, right? When the output is array. So now Yogi sir, you've asked what is the difference between, how do we know the difference between array? So now if you look at strings, the string is directly gets printed, but when you create an array, that is, how do you create an array? Like for example, here we have imported Numpy as NP, and then let's say first create a variable A, and we, instead of arrange is basically a sequence of numbers. Array is what we have to input, what numbers we want, right? So now the first variable has 42, which was added into that particular array. Then we had one row, which is 1 till 5, right? So now b equal to Numpy's array function runs and creates from 1 to 5, right? So once you run this, you can see that, okay, that we are going to print first A, then run this. So, and it is 42 is one element in that particular array, and if I'm going to run B, it is going to be the second array. Now what happens if you want bigger arrays, right? A 2 by 2 array, 2 by 2 as in there is X and Y, there's rows and columns, right? So now if I'm going to run this and print the new array, is going to come in this particular fashion: the first row, the second row, and you can see that this is in kind of a rows and columns kind of a fashion. right? Similarly with you want to create a depth also to it, not just length and width, then you create in this particular fashion. First you give a 2D array and then you close it, then you give another 2D array, right? So this is one particular array. When you give a comma, it becomes a 2D array, and when you give a comma between arrays, it becomes, you know, a 3-dimensional. So when I run this and print D, you can see that the first array is 1 to 3 the first row and 4 to 6 the second row, and the next array is beneath it, right? So it's a 3-dimensional one, right? So this, if it was only 1 to 3, it is you know, just one single row, which is 1D array. When you have 2 columns in it, 2 rows in it, it has become a 2D array. When you have another layer, it has become a 3-dimensional array, right? So now how do you know what is the dimension of that particular array? So you use the function with the array dot in dimension, right? So when you run this, you'll know that this is the array and this is the dimension in that particular array. So this is a 3-dimensional array, right? So how many of you understood what is a 3-dimensional array and how do you use arrays in Numpy, right? Type U in the chat box.